Chemical foundations. Let's start with the results of the scientific method. The first thing I want to point out is the fact that all results of the scientific method, they must be reproducible in order for us to consider them as a theory or a law. So results must be reproducible. Now, there's a big difference between a theory and a law, just like there's a difference between accuracy and precision. A theory explains a body of facts, and a law can be based on those facts. So a theory takes a set given fact, and over again, it applies an explanation. If that explanation works over and over again, then it's considered a theory. Now, a law is just a summary of an observed or measurable behavior. The law of gravity is the easiest thing. The law of gravity says things will drop. Okay, you can repeat this over and over again. It does not explain why. It merely explains that things will drop. So a theory, this works on the because or the why. That should be an A. Okay? This works on the because or the why. So a couple of laws here is the law of conservation of mass. The mass of the reactants must equal the mass of the products. Law of conservation of energy. Energy cannot be created nor destroyed. I'm sure you've heard that many times. So a summary of theory versus law is a law summarizes what happens. A theory, a model is a type of theory, is an attempt to explain why it happens. Now we're switching topics. Let's switch colors. Okay. Handling numbers. Let's look at sig figs again. For sig figs, remember the simplest way to simplify sig figs is if there's a decimal point, count from the first non-zero and move to the right. Go this way. If there is not a decimal, count from the first non-zero moving to the left. If you simply follow that, that's all of sig figs. You don't need to memorize all the other rules. Now the rules for calculations with sig figs, such as when we use dimensional analysis, addition and subtraction, least decimal places. Multiplication, division, least sig figs. In the printed problem. Okay? So that means if one of your conversions is 12 feet per 1 inch, neither one of those affect your sig figs because those are just a conversion. And that also goes into the next part. Sig figs do not come from counting numbers, constants, or defined conversions. These do not count. Okay. So that means that a mass from the periodic table, that doesn't count for your sig fig. Okay. A conversion, 12 feet are in 1 inch. That doesn't count for your conversions, for your sig figs, okay? For your sig figs, it has to come from a measurable or a measured number. It comes from a measured number. Because significant digits are to keep the significance of that measurement throughout your calculations. So it only comes from your measured numbers. For dimensional analysis, let the units do the work for you. Okay, if you struggle with dimensional analysis, put all of your units first to make sure that they cancel. If they don't cancel, you've already messed up. Let's figure that out before you waste your time putting in all the numbers. Now, here are 3 more very important laws, so I'm going to put them back in that original color. Law of conservation of matter, law of definite proportions, law of multiple proportions. Okay. Law of conservation of matter. Well, the words match the law of conservation of energy, so it is matter cannot be created nor destroyed. This is also the basis or the reason why chemical equations must be balanced. If I say H2 plus O2 makes H2O, I am saying something destroyed an oxygen atom, which matter cannot be created nor destroyed. So this isn't what is realistically happening. We must balance the equation to find out what is realistically happening. Okay? Law of definite proportions. A given compound will always have the exact same proportions of elements by mass. H2O is always 2 hydrogens, 1 oxygen. If it is 3 H's and 1 oxygen, that's no longer water. That's something entirely different. Okay? Law of multiple proportions is when 2 elements combine to form a series of compounds. The ratio of the masses of the elements can always be reduced to a simple whole number ratio. Now this is going to lead into empirical and molecular formulas. Okay. We will cover these further on more, but I'm going to put the example here. So for molecular formula, C6H12O6, this is normally the first large molecule you have to memorize. Its empirical formula, its most simplified formula would be CH2O. Right, that's its most simplified formula. Another molecular formula that would have the same empirical formula would be C8H16O8. And because these have the same empirical formula, these two molecules have a relationship. So this law of multiple proportions is the fact that we can have multiple proportions that simplify down to the simplest ratio. Okay? So these names are very descriptive. That's something very convenient about science is we normally name things to describe what they are. So even if you struggle with, I can't remember what that is, it's not a matter of memorization, it's a matter of logic. Law of multiple proportions. So we're thinking about multiple proportions of these compounds. I'm not going to cover the elements, the atom, or the nucleus. Make sure you come back for that. I'm just going to point out a couple things. For my subatomic particles, a proton defines the atomic number. Therefore, it is responsible for the identity of the element. If I say something is 6 protons, I am saying it is carbon. That is the definition of it. For a neutron, it is responsible for isotopes, and it alters atomic mass number. For an electron, there's a huge typo here. Make sure you fix this. Where it says added and lost, we need to switch those. If an electron is lost, well, now I have more protons than I have electrons. I become positive, so I'm a cation. Cations are positive, like paws that a cat has. Cations are positive. If I gain electrons, I become negative. I've gained more negative, so I become a negative ion. A in ion, a negative ion. Okay. These two are very important terms. You need to make sure you get these down. A negative ion and cations are positive. Now, the one last thing for electrons is they are responsible for bonding and hence reaction and ionization energies. Now, the way we can depict these symbols with their important numbers. If I have my element symbol with a number on top and a number on bottom, that would be my mass over my atomic number. You can remember that because if I subtract these two, then what am I going to get? My number of neutrons, right? Mass minus atomic number gives me my number of neutrons. Now, this up here, notice how there isn't a charge here, but I left you a blank to remind you this is where a charge would go. Helium is not going to have a charge. It's a noble gas. Okay. For isotopes, molecules, and ions, you make sure you read through all of this. For molecular formula and structural formula, make sure you read through these as well. Where it says ionic solid, we want to point out the fact that it uses the term electrostatic forces. This is going to be a term we use very often. Electrostatic forces means that attraction of positive and negative. Okay, electrostatic forces. That's very crucial in understanding anything to do with ionic because those are ions, positives and negatives. Now we have our different types of ions listed here. Read through here in your homework tonight is to fill in this table. The one hint I will give you is it is possible to be both an ion and an isotope. Okay. So an atom is something without a charge, has equal number of protons and electrons. A cation has more protons than electrons because it is positive. An anion has more electrons than protons because it is negative. And an isotope has a differing number of neutrons than the mass that comes from the periodic table.